Okay, everybody, let's get started. We got work to do here. We got a big meeting today. I've adjourned this meeting with you Dream Team mathematicians to save this company. And look at what you've done. Our profits have gone nothing but down. Pirate, you told me my profits decreased by 200%? That's impossible. Everybody knows that percents cannot be over 100. You're fired. What? They can be over 100%? I must have slept through that math class. I can't take it anymore. I quit. It's time to go back to teaching. I can yell at kids more there. All right, everybody, here we go. It's time to start week 4. Online learning. Let us begin by taking a look at our problems of the day from last week. Here we go, everybody. Here's your... we got to start off with our quote of the week. Quote of the week comes from the Crow Indians. That's right. Way back when they knew that you already possess everything necessary to become great. It is within you. Let it come out, everybody. Here we go. Problem of the day. Here is the answer to number 1. There are many different answers, everybody. We can rotate this shape all different ways so that this face does not always have to be in the front. Take a look at your answers. Remember that this 1, 7, 2, 8 face could be on any of these 6 sides. You know if you got it right. Take a look, everybody. Number 2, we said we have to put 6 bottles in here so that we have no odd rows or columns. They have to be even, or of course 0, which isn't necessarily odd nor even, but we'll accept zeros as well. Take a look at what you've done, everybody. Check those columns. Does it have just 1 in it? Then you're wrong. Here we go. Here is one possible solution. Remember, this could be moved around lots of different ways, spread out, scrunched together, but this one works. Take a look at this one, everybody. I'm going to put these 2, and these 2, and these 2. Take a look at that, everybody. Look at my rows. 2, 2, 2, 0. Well, that checks out. Now let's check our columns. 0, 0, 2, 2, 2, 0. That's a solution, everybody. Congratulations if you got it right. If not, try again. Well, I guess you can't. Now you know the answer. All right, everybody, let's move right along. We're starting chapter 10 today. That's right. Chapter 10. What's it about? Surface area and volume. That means 3-dimensional objects, everybody. 3-dimensional objects. I'm going to forward you these notes, but let's talk about them real quick. We are, of course, talking about solid figures. 3 different kinds of solid figures we're going to talk about in this class this week, and next week, and the week after. Let's start off talking about a cone, everybody. A cone has one flat circular base and a curved lateral surface with that common vertex point right here. I think y'all know what a cone is. Take a look at number 2, everybody. We're also going to talk about cylinders. A cylinder has 2 flat bases and a curved lateral face. It rolls in a straight line, whereas the cone is only going to roll around in circles. Maybe more importantly, everybody, we got to talk about our polyhedrons. Polyhedrons have flat faces that are polygons. Nothing curved, nothing curved. Polyhedrons have to be flat. They won't roll. Maybe let's first talk about prisms, everybody. A prism has 2 congruent, that means the same, and parallel, that means they would never cross, bases. They also have lateral faces, which you might call sides, but in math we call them faces, that are rectangles, and they're named for the shape of its base. Well, everybody, I like to imagine our solids as kind of floating without gravity. Now notice, I could rest it down just like this. That does not make this side the base. No, that doesn't make sense. Because what? Now that side's the base, then that side's the base. You can't have it like that. So while this object is spinning in your imagination, floating in space, you have to look for these rectangle faces. Look at these rectangular faces, everybody. That makes these 2 guys the bases. They are in the shape of a triangle, so this is called a That's right, a triangular prism. Notice that the bases are parallel, but the lateral faces are not, are they, everybody? These guys aren't parallel. They're not parallel, but they are rectangles. That makes these guys the faces and these two guys the bases. Another example of a prism is right here. Notice all of these rectangular faces. None of them are parallel because this is a pentagonal prism. Pentagonal. The two pentagons, they are what's parallel. Therefore, they are the bases. Name for the shape of its base. It's a prism. It's a pentagonal prism. Moving right along, everybody. Besides prisms, we also have pyramids. Pyramids have only one base. Their lateral faces are triangles, not rectangles, triangles, and they have that common vertex, just like that cone. And just like the prism, they are named for the shape of their base. Well, let's take a look at one of them anyway, everybody. This here is a pyramid. Notice the lateral faces are all triangles, and its base is a hexagon, making it a hexagonal pyramid. Of course, we can make a pyramid out of almost any shape. Well, nothing less than a triangle, but anything triangle or more, we can make that into a pyramid. Well, everybody, we are going to start chapter 10 with a bunch of worksheets. That's right, a bunch. I'm going to have you guys download some notes. I want you to take a good look at this one page that has a picture of all these different prisms and pyramids and use that to answer the questions on your 3 worksheets. You heard me. 3 handouts. Don't worry, none of them are too bad. I'm gonna make a suggestion in what order you should do them. That'll make them a little bit easier, in my opinion. I think the first handout's the hardest, so don't get overwhelmed just because the first one takes you too long. The next 2 will go much faster, I promise. And I'll see you tomorrow.